In this video, we're going to take the vectors that we created in the first part of the tutorial and we're going to show you how to assign a V-carving toolpath and a profile cutout toolpath to them to create the sign that you can see on the screen. We're really going to focus on the V-carving toolpath for this example. In a moment, I'm just going to take a couple of minutes to discuss some of the key aspects to getting the best results with V-carving. Then we'll go ahead and actually open the file itself, apply a V-carving toolpath to the main information in the sign and show you the effects of using different angled V-bits and how to preview that. Then we'll look at working with the preview, showing you how to apply different colours and finishes to it and creating files that you could save and send to a customer for approval. We'll also look at how to save the toolpaths and finally how to create some simple dimensioning to maybe help create a setup sheet that you can use in order to see the size and orientation of the part when you get to the machine. Before we go into the example itself, I'd just like to take a couple of minutes to talk about some important concepts and things to be aware of when V-carving. V-carving itself is one of the easiest ways to create really attractive decorative elements with a CNC machine. Whether you're cutting a graphic or whether you're cutting text, by using V-carving it's very fast to both calculate it within the software and it's also generally quite quick to machine it in order to ultimately create something which is effectively a 3D look on a part once you finish carving it. Some things that are important to understand with V-carving is that the depth is determined by the tool angle and the width of the vectors. The wider the vectors are, the further down into the material the tool will be able to fit. So if you imagine a triangle drawn down at the angle of the tool, you can see as that triangle gets bigger or as the vectors are wider, then the tool is going to be able to go deeper. Understanding the fact that the V-carving is determined by the angle of the tool and the width of the vectors is really important to choosing appropriate tooling when you come to do your machining and using a V-carve strategy. There are a number of things that it's important to be aware of if you want to get good results with V-carving, and many of these are specifically to do with things on the machine itself. The first of these is that you need to ensure that you have nice flat material. Related to this is having a level machine. If you don't have a level machine and flat material, then you're not going to consistently have the tip of the tool, the point of the tool lifting out of the material at the right place, and therefore you won't achieve the nice sharp corners that really set off a good quality V-carving. Also, in the same vein as that, is the fact that you should have your Z0 setting accurate to the top of the material. Again, this is all to do with getting that tip of the tool to leave the material to give yourself nice sharp points at that surface. Generally speaking, it's going to be easier to do that by setting the Z0 on the top of the block rather than off the table, because that way you don't need to be as worried about having the exact thickness of your material specified, because everything will be relative from the surface down. Also need to have very accurately sized tools. The software is going to require you to tell it the angle of tool you're using. Now in some cases you may believe that you have a 90-degree angle bit, but you should always measure it just to be sure, because if it's even 1 or 2 degrees different to that, then you will need to enter the correct value in order for the software to calculate accurate toolpaths and for you to get the right results when you machine it. So make sure you measure the angle of your bit, and if it's 89 or 91 degrees or even half a degree out, then make sure you specify that accurately when you set up your toolpath. Another aspect that's important with regard to the tooling is the fact your tools need to be sharp, and they should end in a point rather than a small flat. You should make sure that the tooling has not got chipped. Any of these things would affect the quality of that point that you're going to get at the bottom of the shape that you're carving. Finally, another aspect not related to the physical aspects of the machine is that within the software you need to have nice, clean, closed vectors. By having clean, smooth lines, that's going to ensure you get a nice, clean, smooth carving. The vectors need to be closed so that software knows the area within that you want to V-carve. It won't actually accept open vectors for V-carving, and it would give you a warning about that if you tried to use them. In addition to that, you need to try and avoid these vectors being overlapping. If they're overlapping, then it's not clear to the software necessarily which area it is that you're trying to V-carve within. So again, just things to make sure of within the software: nice, clean, closed vectors, and avoid vectors that are overlapping. If you do have a design that has overlapping vectors in it, then what you can do is machine it in multiple V-carve toolpaths. So you might machine one set with one V-carving toolpath, then the vectors that would have overlapped with that you could create as a different toolpath, and then you could output those using the same tool. So let's go ahead and open the data for our example. I'm going to click on the icon to open an existing file, and from the project folder I'm going to select the vectors that we created in the first part of this tutorial when we dealt with all the design layout. That file's called 5starcoffeevector.crv. We hit open. There we can see this design. Now we're going to go over to the toolpath tab. So we can come under 2D view control, click on the icon here to switch to toolpath tab. And before we calculate any toolpaths, first job is always to set up our material. I'm going to come over and click on the set button here. Material for this is going to be 3/4 of an inch. And for V-carving, typically it's best to set 0 off the top of the block. That means that your V-carving is all going to be relative to the surface of the material and give us those all important corners. In this case, for machining, I'm going to move my datum position to the lower left. So I'm going to click in the corner here. So now X0, Y0 is in the lower left corner. I'm going to check the values for my rapid gaps, for the home position. If I'm happy with all of those, I can hit OK. Now it's important to note, if you're planning to machine this example yourself, whatever values you use for the material setup and the toolpaths need to be safe for your particular setup, your tooling, your material and your machine. So for this particular design, what I would like to do is V-carve everything except the outermost border vector. So what I'm going to do is select all the vectors and then just deselect that one. So we'll come up to Edit, choose the option to select all vectors, or Control A as the shortcut for that would be. Then holding the Shift key down, I'm just going to select the outermost vectors to remove it from the selection. So now we have everything picked except that outermost vector. We can see that indicated within the 2D view. Now I'm going to click on the icon to go into the V-carving toolpath. We're going to start at 0, so start depth is going to be 0, the top surface of the material, and we're going to V-carve down from that. I'm going to show you a couple of different examples using different sizes of tools here to show you how the angle has an effect on what the part will look like. Let's start in this case by using a pretty wide angle V-bit, 120 degrees. You can see I don't currently have one of those in the tool database here, so if you don't have one in yours then you can add one, or in this case what I'm going to do is make a copy of this 90 degree tool, and then I'm going to change that so the included angle is 120, and I'm going to change the name as well to say 120 degree V-bit 2. Now when we hit apply, the software will warn me that the current pass depth, which was picked up from the tool we copied, is too big for that tool. It means that there's not enough depth based on the angle and the width of the tool that we've got there. So the max I could do is 0.361, so I'm going to hit OK, change my pass depth to 0.35. I'm going to leave all the other parameters the same, go ahead and hit OK. So we have 120 degree V-bit selected. I'm going to leave all the other options here. I'm not using a flat area clearance tool because I don't have a flat area specified. I want to V-carve all the way down to the full depth based on the angle of the tool and the width of the vectors. Change the name of this, we'll call the toolpath V-carve, hit calculate, and we can see the toolpath there, but until we preview it we don't really get a sense of how this is going to look, because only then will I see the shape of the tool actually applied to my material along the lines that we've specified based on the vectors here. So let's go over and click on the button to preview selected toolpath, and there we can see what my design will look like machined with a 120 degree V-bit. So quite shallow angle on this. Can be very nice to use quite shallow angles if you're planning to do something like gild it, because the shallower angles will allow the light to get in and reflect off the gold leaf. Let's change this though and look at the effect it would have to go with a much steeper angled tool. So to edit this toolpath, we can just double click on its name from the toolpath list. That will open it up again, and from the tool area of the form I'm going to hit select, and I'm going to choose the 60-degree V-bit. So this is a pretty sharp engraving tool. I'm going to hit OK, hit calculate, so that'll replace my toolpath with one that's now calculated for a 60-degree V-bit. We can still see the preview from the 120 degree there, but if I say preview selected toolpath, then that's going to machine into that, and there you can see what the difference would be if we were using a 60 degree tool. So you can see that's much sharper and deeper. And again, as we've discussed, this is purely based on the angle of the tool as it fits within the vectors here. So we can see in the angle as it comes around the top part of the S here is going to be quite shallow and coming up, lifting its corner to the top of the material in the serif. Then as it comes around and into the wider area, it's just going to get deeper and deeper as that tool can fit further down, effectively riding the rails of the vector. So I think for this job I probably want somewhere part way between. So again, if I want to edit the toolpath, I could double click it, or we could close here, select it and go to the edit toolpath icon. From the tool area I'm going to hit select, and I'm just going to select a 90-degree V-bit, nice wide sign making V-bit there, 1 1/4 inches across. I'm going to hit calculate. This time I need to reset the preview, otherwise I won't see anything happen because the previous tool was a 60-degree V-bit, steeper angle. Then we can say preview selected toolpath, and there we can see what that will look like machined with a 90-degree V-bit. So now I want to just go ahead and do my cutout toolpath. So let's close the preview. Let's click on the tab here to go back to the 2D view. I'm going to select the outermost vector on its own. We'll just click on that, come to the profile toolpath options. I'm going to keep this very simple. I'm going to cut through the material, which is 3/4 inch thick. I'm going to go with a 1/4 inch end mill. So here we can see we have that tool selected. If you don't have that tool selected, then hit select, choose it from the tool database. And for this, because we're cutting fairly soft material, I'm going to hit edit, and I'm going to change my pass depth to be 0.25 inch and hit OK. So now we're going to do this in 3 passes. I want to cut outside of this vector, and I'm just going to call the toolpath profile cutout and hit calculate. Just take all the other defaults there. Then I'm going to say preview selected vector. There we can see our cutout toolpath. If we wanted to, we could add tabs to that toolpath to hold the part in place if we don't have another method for hold down. If we don't have tabs, one benefit in the preview is that we can double click on this material here to delete the waste material. So if I just go on the area that I want to get rid of and double click it, then that will disappear and leave me with just the sign. So now we can actually take this, save the preview image and send that to the customer if we wanted. We could also add additional colours or finishes to the toolpaths or to the surface of our material in order to give the customer different options. For instance, in this case I might say that I'd like my sign to have a solid colour rather than be wooden, so we could say solid colour. We can choose from the drop down here what kind of a colour we'd like. So maybe go with something like a dark blue there. And then I could come and say for the V carving, I'd like to give that toolpath a colour, so I can check the option here for toolpath colour, click on the down arrow here, and then we might want to choose different coloured painted text to show different effects that we could offer the customer depending what they were looking for here. We could also change the material colour as well, so we could maybe go with a much lighter colour for the material and then a darker colour for the text. Sometimes a black is a little strong, so going with a grey will make it a little easier still to see the V carving shape in the bottom there. Once we're happy with our colour scheme, we can click on the button to say Save Preview Image, and we can choose one of the different image file types, save that onto the disk, and then you could use it perhaps for emailing to the customer, Maybe you'd want to send them a variety of different color schemes or something like that. You could also use these images to post them on your website to give people an idea of the type of work that you can do. In this case, I think that yellow is probably a little harsh to look at, so I'm going to go back to Canadian Maple for our material setting here. Once I'm finished with the preview, we can hit close, and at this point I may be ready to save my toolpath to send to the CNC. To do that, we just choose the toolpath we want to save from the list, click on the icon to save the toolpath, make sure the correct one is in the list here to be saved, choose the appropriate post-processor for our machine, so we just need to look through the list and match that up. You should only really need to do that once because the software will remember whichever post-processor you select. So assuming you only have one machine, once you have the correct one selected, then you should always be able to just come into here and not have to worry about choosing that. Then we're going to click on the button that says Save Toolpaths. We'll find the folder we want to save it into, give the file a name, hit Save, then go ahead and choose the other toolpath here, the profile. Again, just double check in the list, click on the Save Toolpaths buttons, give that a name and hit Save, and then those files could be transferred over to the CNC for me to run them. Now sometimes it could be beneficial to have a little printout of your part in order to help you to do your setup on the machine, especially if you're maybe not planning to run things immediately. Maybe you've got several jobs that you're doing design work for. So what you could do in this case, let's close the Save Toolpaths form. Let's go over to the 2D view. We'll click on the tab here. And what you might want to do is just print out the image that you've got here. So you could always go up to File and Print. We can do the print preview here to see how that part's going to look. Or it may be that you'd like to add some dimensioning to it just to give yourself an indication of perhaps where the part's positioned in the material or how large the part is. If we go back to the Drawing tab, we can click on the icon here to switch to the Drawing tab, which will minimize the Toolpaths tab for us. We have the ability to add simple dimensions to our 2D drawing. The dimensioning within the software has not really been designed to do sort of full drafting technical drawing layouts, but it's perfect for throwing on a few dimensions just to give us a reference perhaps to how big the part is, or perhaps to pick out certain features, certain radiuses, things like that. If I click on the dimension icon, what I can do is choose what type of dimension I want. In this case, perhaps I'm just going to put simple vertical and horizontal dimensions on it. Start by clicking horizontal dimension, choose an appropriate font, and this is just going to choose a font from the list, so maybe we'll come up and pick something like Arial. You can choose things like the text height, decimal places, the offset from the lines there, so maybe we'll switch to 3 decimal places here. Text height I'll make 1/4 of an inch. Then I'm going to come into the view, I'm going to snap to this corner, snap to this corner, and then just pull this up, and then we'll just click there so that that's put in the value for me. And then I might say that I want a vertical dimension, and perhaps we'll go from the top to the bottom here and then drag this over, and there we can see the dimensions been added for that. If we wanted to, while we're creating dimensions, we could tell the software to put them on a specific layer. And that can be very helpful. You could create a layer specifically called dimensions. That would allow you to easily switch them on and off if you were actually labeling your part with quite a few different dimensions. In this case, as I say, they might just be helpful to us to remind us of the size of the part. If I close that now, we could go ahead and file and print that and make some notes on it if we wanted to, and then that would help us when we came to do our setup on the machine to remind us about the orientation for the job and its overall size. So let's go ahead at this point and save our file. Go up to File, Save As, and I'm going to call this 5-Star Coffee, and then we'll just put a TP on it to show that it's got toolpaths in it, .crv, and go ahead and save that in the project folder if you want to take a look at the setup for this. At this point in time we've pretty much finished, but let's take a moment to summarize some of the things we've looked at and discussed in this particular presentation. You saw at the start we talked a little bit about V-carving and the general process for V-carving, important things to be aware of to get good results with it. It is one of the most powerful and efficient ways that you can create carved parts with a CNC, so it is good to get a really detailed understanding of it, how things like the angle of the tool, the width of the vectors and the quality of the vectors will affect your output. We then looked at how quick and easy it was to generate a V-carved toolpath. We just selected the vectors we wanted to machine, told it what angle tool we were using. The software automatically generated those toolpaths for us, so we could quickly see in the preview what the effect of that angle and width of the vectors was going to be like. You saw how that varied depending on the angle we chose. We worked through a 120 degree, 60 degree and a 90 degree V-bit, previewing each of those. We showed you then how to do a profile pass around the outside. We removed the waste material using the double click when we're in the preview. Showed you how we can cycle through different colours and finishes for the preview, save those images to show our customer for approval. Finally, we looked at saving the toolpaths, and then for our own benefit we threw a couple of dimensions in the 2D view in order to help us create a setup sheet we could use when we got to the machine to just verify some of the sizing information. That concludes this particular example.